Hi everyone. So today we're going to talk about a brief introduction to rotational motion. So far we've talked about circular motion. This is a type of rotational motion, right? This is where we have an object that's moving along a circular path. We know that this object is accelerating because their velocity is changing, right? Whether it stays in the same speed or not, no matter what, we're changing our direction, right? Which means we're changing our velocity. This acceleration is pointed towards the center of the circular path, right? And because of this, we know our net force has to be towards the center of our circle as well, right? F equals ma. And therefore, our centripetal force is pointing towards the center of the circle. Now, a little preview of what's to come. So we're going to analyze the motion of a rotating rigid object, right? Sometimes this rigid object is known as a rigid body. That's a very common physics term. That's probably what I'll end up saying in class. So what a rigid object is an object that has a definite unchanging shape. Right? Now, when an object spins, it spins about its center of mass. Right? And what is the center of mass? This is basically the location of the average position of matter in the object. So if our object is of a uniform shape and a uniform density, it's going to be at the geometric center of that object. So for example, here this basketball, it's a rigid body, right? At least we'll estimate it being a rigid body. It has a definite unchanging shape. Here it is spinning about its center of mass, and this basketball, its center of mass is going to be at the center of the sphere. So at the center of the basketball. Note that the center of mass may not be at the center of the object, right? If the object has a non-uniform density, so it has more mass on the left side of the object than the right-hand side of the object, the center of mass is going to be more towards the left of the object. If you want to talk about more of this in class, you're welcome to ask me. Now, when it comes to motion, we have two types of motion. The first is rotational motion, and that's the spinning aspect of an object's motion, right? Spinning about its center of mass. We also have translational motion, right? So this is the non-spinning aspect of an object's motion. So think what we've been talking about with linear motion for most of the school year, that's a type of translational motion. Actually, we can analyze this translational motion as the motion of the object's center of mass. I have a little video to explain what I mean there. But first, when it comes to these types of motions, we can analyze and think about these separately. Right? We can remove the rotational motion away from the translational motion and think about them separately, which is actually what we've been already doing with translational motion. We've solely thought about translational motion, not worrying about the spinning aspect of the object's motion. So here I have an example of translational motion, right? So we have a penguin here that is moving in a straight line. This is translational motion, right? The penguin's not spinning at all. It's just moving translationally. So this example is solely translational motion. Here we have an example of solely rotational motion, right? This seal, is that a seal? I think it's a seal. The seal is just spinning or rotating in a circle. It's not moving translationally at all. It's just rotating. So this is just rotational motion. Here we have an example of both translational and rotational motion. So if you look at the basketball in this GIF, it is both moving translationally, right, moving from the basketball player's hand to almost the hoop, hitting the net. So it's moving translationally, but it's also moving rotationally because the basketball is spinning while it is moving rotationally, right? So this is an example of both the type of motion. Now remember when I said that the translational motion of an object can be just seen as the motion of the center of mass. This is actually what we've been doing this whole school year. For any object, say we're talking about throwing a ball in the air, we consider it to be a point object. Really what we're doing is analyzing the motion of the center of mass. Though I did not clearly state that, this is what we're doing. So here in this video, what we're going to see is actually some objects that are spinning in the air, right, having both translational and rotational object, but they've drawn a fluorescent dot at the location of the center of mass, and you can analyze the center of mass motion of the object. and see if the motion looks familiar to you. Ugh, this is the school Wi-Fi being slow. Let's try this again. Alright, so I can't get the website to work. So, new plan. Go to that link there. You could also search in YouTube MIT Center of Mass Motion, and that should pop up this video. But watch the video and you can observe the parabolic motion of the center of mass while the object is both spinning, moving, rotationally and translationally. Right? Alright, so that's what I have for you today, and I hope you enjoyed that video. It's pretty cool. And I will see you next video.